Hey my friends, welcome back. System design interview is well adopted in the technical company for assessing the candidates' communication and problem-solving skill. The interview is open-ended, it's not easy to practice, and even do a mock interview is quite costly. And in this video, I'm gonna share how I use ChatGPT to practice system design interview. In this video, we cover what is system design interview and what to practice. And lastly, I will show you a real demo with ChatGPT. Let's get started. What is system design interview? System design interview is about 1 hour session. The interviewee needs to collaborate with interviewer to solve a system design problem. Usually, the problem is big and open-ended. For example, design a YouTube, design a key value database, or maybe design a UI shortening service. On thinking of those problems in the real world, it's impossible to cover all the details within 1 hour. The interviewee needs to drive the conversation to touch most important part. Unfortunately, there is no pattern to follow. Interviewee has to drive the conversation to the most comfortable area and show their expertise in the system design. Without practicing, it is rare to get a good outcome. So let's practice. What to practice? Most of the system design interview will cover 3 sections. First, requirement confirmation. The interviewee has to confirm requirement including functional and non-functional requirements. Second, high-level design. Getting interviewer buy-in, then keep moving. Lastly, detailed system design. Interviewee narrow down one aspect and dive into the details and show their expertise. Throughout the whole process, interviewer also need to do thinking aloud and driving the conversation. Keep the interviewer engaged so that they can ask questions accordingly and they can easily look into what they are after. Drawing while talking. We need to visualize the system throughout the conversations. Think about it. Doing all those kind of stuff all together under the time pressure and the interview pressure is damn so hard. Only thing we can do before attending those kind of interview is practicing. Luckily, the ChatGPT with 4.0 large language model can help us practice easily. Let's jump to the next section, how to practice it. How to do mock interview with ChatGPT. There are something we need to prepare. The first thing is the ChatGPT account, or maybe you are able to access ChatGPT. We also need the Mac app or an iOS or Android app on your phone so we can start the vocal conversation. And lastly, we need to prepare the problem. In the upcoming video, I'm gonna show my practice with a problem, design a UI shortening service. Here is the instruction. You can follow the instruction to practice your own problem. First, prompting. Tell the ChatGPT you're gonna help me to do a mock interview. Then provide some instruction telling ChatGPT, don't provide answer, don't give me direction. If you don't do that, ChatGPT think they're gonna solve the problem for us. So let us do, not ChatGPT do it. Lastly, provide the problem. Design your shortening service. After the prompting, we can click the button to start the conversation mode. So we can draw our design in a whiteboard and describe it to the ChatGPT. On recording the video, the ChatGPT vision mode haven't been enabled for me, so I can't let the ChatGPT see my design from the whiteboard. But the vocal communication is also effective. This is all about how to use ChatGPT to do the mock interview. For the rest of the 25 minutes is a real demo from my practice. Hopefully, you can follow my demo and do your own practice. Hey, what are we doing here?
I understand. When you're ready to start the mock interview, please let me know and we can dive right into the system design exercise.
Yeah, and today you're gonna act as an interviewer and help me do the mock interview for your system design problem. Don't give me the answer. Don't suggest me the direction. Just like interviewer, chat with me and follow my flow.
Got it. I'll follow your lead. Let's get started with the mock interview. Imagine you're tasked with designing a real-time collaborative drawing application similar to Canva's whiteboard feature. Users should be able to draw, add text, and make shapes in real time, and these changes should be visible to all other users on the same board. How would you approach designing this system? You can start with any part of the system you feel comfortable with.
That's really great question. Maybe let's don't do this. Today I'm going to focus on an URL shortening service. Should we choose this problem?
Sure, let's go with the URL shortening service. How would you begin designing the system? Feel free to start with any aspect you prefer.
Yeah, for URL shortening system, first thing I want to clarify the requirement from user point of view. I have tried URL shortening before. The shortening service is kind of the user submit a URL, maybe a long URL, has been to the server, and shortened to maybe really short length of the URL, so that the user can share in the internet, maybe like Twitter, easily. And on the other side, when another user viewer click the shorten URL, it can open the original URL.
Great start. That's a good understanding of the basic functionality. Can you tell me about the scale you expect for this service? For instance, how many URLs might be shortened per month, and how much traffic you expect for these shortened URLs?
Oh, there will be a lot. It really depends on traffic. Is there any traffic requirements or scalability requirements for this service?
Let's assume the service will handle about 100 million URL shortenings per month and should be able to handle about 10,000 requests per second for redirections. How would you design the system to handle this scale?
Oh, that's a really a large scale system. The scale up won't help. I need to consider scale out. Let's talk about I will consider it in the detailed design for this non-functional requirement.
That sounds good. Let's start with a high-level overview of your design for this URL shortening service. What components would you include to handle both shortening URLs and redirecting requests efficiently?
Yeah, before I dive into the high-level components, just another thing is on creating URL, usually the shortening service has tiers, free tiers, paid tiers. They are created different URL. So is there any root limit we want to apply for the user?
Good point. For this mock scenario, let's assume we have a free tier that allows up to 1,000 URL shortenings per user per month, and a paid tier with no limit. How would you incorporate these constraints into your design?
Yeah, we probably need a really limited component later on, and also the configuration service. And payment is another part we want to cover today. Maybe use third-party payment if you really need. We can touch there. So we can jump to the high-level component, then break down to the details design.
Sounds good. Let's start with the high-level components. Can you outline the main components of your URL shortening service and describe the role of each component?
Yeah, let's get started. And for this service, it has two parts. One is a creator who created the URL shortening, and the input. The input is the URL, and the output is a shortened URL and stored in a database. In a database, we can choose a database in the detailed design and based on the throughput. And another side is the consumer side. When the consumer hits the shortened URL, the input is click the shortened URL, and I need to redirect to, I need to load the mapping, the kind of the shortened URL to the original URL mapping, and redirect to the original URL.
Great, you've outlined the core functionality. Now can you break down these high-level components into more detailed ones?
Yeah, let's start from the creator part.
What kind of database might you use, and how would you handle the URL generation and redirection at a large scale?
Yeah, so let's get started from the creator parts. And if when the customer, let's assume there the client side is a web page, is it a good assumption?
Yes, assuming a client-side web page is a good start. So when the customer enters a URL to be shortened on the client-side web page, what happens next in your system?
Yep. When the client submit a URL, let's assume I'm gonna expose the RESTful API and running RESTful API and running on a cloud service. I assume AWS. And because we are handling a large amount of the traffic, so the first thing is it hit the API gateway, then link to the load balancer, and there are a bunch of the EC load balancer, and there are a bunch of ECS services handle the request, and with also auto scaling group. Alternatively, I can choose the AWS Lambda for some search request.
Excellent. So after the request hits the ECS services or AWS Lambda, what would be the next step in processing this URL shortening request? How would the service generate and store the shortened URL?
Yep, the next part is when I get the URL, these are called the shortening service, shortening component. The shortening component will take the URL input and do the hash function. And this hash function is really unique, because we want to generate the URL unique, ensure, given the URL in a time period is unique.
That makes sense. After generating the unique hash for the URL, where and how would you store this mapping between the original URL and the shortened hash?
Yeah, this one, you can see here the shortened URL to shortened URL to the original URL. This is pretty much perfect for key value store. I'm gonna choose the AWS Lambda DB for storing the shortening URL, and the key is shorted URL.
Using DynamoDB sounds like a good choice for handling high throughput with low latency. Once you have stored the mapping in DynamoDB, what would the response to the client look like? And how would you handle redirects when a user clicks on a shortened URL?
Yeah, that's a really good point. After I store this kind of mapping, I will return the shortened URL to the customer. And we also need a expiration for this shortened URL. That's another part, details. We can jump into the consumer part.
Great, let's move on to the consumer part. When a user clicks on a shortened URL, what happens next in your system to handle the redirect to the original URL?
Yep, I'm still thinking. When the consumer hits the shortened URL, actually they hit the redirect endpoint. The redirect endpoint will respond to the client. You need a redirect. I think there is the HTTP code called redirect 302, and redirect URL to the original URL. So in the service, I need to load the mapping and look up the original URL from DynamoDB and return to the consumer.
That makes sense. For handling this high volume of requests, how would you ensure that the redirect service remains performant and can handle spikes in traffic?
Yeah, for this service, I would pick because it's just read the mapping from DynamoDB. I would choose the Lambda AWS Lambda the service to handle this kind of request that can support search. And for DynamoDB, it contains the read and write capacity. It support a large scale But just in case if DynamoDB have the bottleneck, we can introduce a cache layer for reading the mapping into something like Redis.
Using AWS Lambda for handling redirection requests and adding a caching layer with Redis for frequently accessed mappings sounds like a solid plan for maintaining performance under high traffic. Would you like to dive deeper into any particular component or discuss any potential challenges and how you might address them?
Yeah, there is from the web. Let's start from the creators. There are some something I'm consider now. The system support. I'm using AWS can support a large scale on handling requests, and there DynamoDB has a really great feature to support high throughput on the read and write. There is a thing. It's on shortened URL, the URL is short, so there the challenge is kind of hashing collision. These are the things we need to handle.
Consideration. How would you ensure that each shortened URL is unique, and how would you handle potential collisions in your hash function?
Yeah, this one, if we got collision, so this kind of we're not only taking the URL as input, maybe take something else as input as well. So it can reduce the collision. Another thing is hash function. We can introduce multiple layer hash. Try to introduce more kind of random seed for the random hashing, so it can reduce the URL. On the other hand, we also need to introduce expiration for each shortened URL, because we are handling 1,000 requests, 100 million shortened URL per month. The shortened URL hash length will be burned out soon, very soon.
Introducing multiple layers of hashing and incorporating additional inputs to the hash function can certainly help in reducing collisions. Adding an expiration policy for shortened URLs will also help manage the reuse of hash values over time. Would you like to discuss how you would implement the expiration policy and manage the cleanup of expired URLs?
This is a really good topic. So for the expiration, I'm not sure does the DynamoDB support expiration for the specific key. If yes, we can use this kind of mechanism to set an expiration for the record in the DynamoDB. If not, we're gonna use something else to expire the shortened URL. And there are some strategies for expire the shortened URL.
DynamoDB does support TTL, time to live for items, which can be used to automatically delete items after a specified time. If you use this feature, it can handle the expiration for you. In case you decide not to use DynamoDB's TTL or need additional control, you could implement a separate cleanup service. This service could periodically scan the database for expired URLs and delete them. Would you like to discuss more about how you could implement this cleanup service or explore other strategies for expiring shortened URLs?
Yeah, this one, yeah.
If we decide to implement a cleanup service for expiring shortened URLs, here's a potential approach. 1. Expiration field. Each entry in DynamoDB would have an additional field that records the expiration timestamp. 2. Scheduled cleanup. You could implement a scheduled Lambda function that runs periodically.
Yeah, let's skip this part. We can use the DynamoDB TTL function, and for the expired URL, let's jump to the consumer part. There's something in the consumer part.
Sure, let's focus on the consumer part. What specific aspects of the consumer part would you like to address next?
Yeah, on the
Is it about handling redirects efficiently, managing high traffic, or something else?
Yeah, I'm thinking of the scaling and the latency because I'm using the kind of LS Lambda and DynamoDB and a cache layer. There are two problems here. From the user point of view, there's a globalization problem. On the shortening part, on the another part, the cache have the expiration policy problem. Let's go on to the first part, is globalization.
For globalization, ensuring low latency and high availability worldwide, here are a few strategies you could consider.
Yeah, I'm going to talk about those problems. You don't need to provide any options. You are interviewer, and I'm going to provide different options and make the trade-off. Hey, you don't need to give me the answer.
Understood. Please go ahead and discuss your options and trade-offs for handling globalization and latency.
Yeah, first thing, after we shorten the URL and I'm thinking the latency because the user can access this kind of service from everywhere and shorten URL everywhere, and latency would be a problem. Now, for example, the people in US, if the server is hosted in US and being accessed from your maybe something like China or some else, they have increased latency. So for these services, this shortened URL is pretty much immutable until it's expired, and it's kind of the static asset. I can push this one to the CDN, and the CDN has the edge services. CDN service can catch this kind of mapping and the client side of the browser can get this kind of mapping faster, and it can reduce the latency. So after we store the data in the DynamoDB, I'm gonna use another service to push this kind of things to CDN.
That sounds like a solid approach. Using a CDN to cache and distribute the shortened URLs globally can significantly reduce latency for users accessing the service from different regions. What's your plan for ensuring that the cache remains up to date and handles the expiration policy effectively?
Yeah, cache keep up to date is depends on one thing. Do we support the shortened URL deletion or support the expiration? If we don't support the shortened URL deletion, should be alright. We just cache it in Redis and keep the same TTL as the DynamoDB. That's fine. If we introduce deletion, there will be a problem.
That's a good point. Handling deletions can indeed complicate the caching strategy. How do you plan to manage cache invalidation if deletions are supported? And what are your thoughts on ensuring the cache and database remain synchronized?
Yeah, there is something called read through or read after approach. After we write the shortened URL into the DynamoDB, we also write into the Redis cache as well as is synchronized. And this approach would introduce a little bit latency on creating side, but this can keep the cache up to date. And
using a write through or write behind approach can definitely help in maintaining cache consistency with DynamoDB. By synchronizing writes to both the database and the cache, you ensure that the cache is always up to date at the cost of a bit more latency during writes. Is there anything else you'd like to explore or any other concerns you have about this design?
I think so far it's good, and there are another consideration within hash and the DynamoDB. There is a fault tolerant consideration. What if the cache goes down and the DynamoDB reads volume from DynamoDB will be large, and we need to provision the DynamoDB read capability carefully and adjust it. And even when we restart the server, we need to warm up the cache.
Those are valid concerns. Ensuring fault tolerance and managing DynamoDB read capacity are crucial for maintaining system performance. How would you approach provisioning DynamoDB read capacity and handling cache warmup to mitigate these issues?
Yep, and the cache warm-up, the things we need another storage to store some hot URL, popular shortened URL. Those would be those URL will facing the high low request. First, we have search there sitting in cache should be alright. If it's sitting in cache and doesn't work, and we will hit to our Redis cache. So on warm up the Redis cache, we need to load from our stored the popular URLs and read and call ingest and put the cache into the Redis cache system for warm up. And meanwhile, we also need to consider the back pressure. We need to add some circuit break to stop some request, and the service won't be harmed by the large volume of requests on hitting to the DynamoDB.
That makes sense. Using a secondary storage to keep track of popular URLs for cache warmup is a good strategy. Implementing circuit breakers to manage back pressure during high load situations will help protect your system from being overwhelmed. Do you have any further thoughts on fault tolerance or other aspects of your design that you'd like to discuss?
Yeah, I'm still thinking. I'm thinking the DynamoDB are already fault tolerance and the data has a partitioned, so this one should be alright. It is a good choice. So far, it's good. I think I pretty much run out of time today, and this is all my design. Any questions from you?
You've done a great job outlining your design and addressing potential challenges. It's clear you've thought through the key aspects of scalability, latency, and fault tolerance for the URL shortening service. If you have any other questions or need further assistance later, feel free to reach out. Good luck with your preparation.
Yeah, could you help me to summarize what I did today and summarize in these sections? First, what's the requirement I confirm, and what's the path, creator and consumer path I clarified, and what's input, and what's the design. And also give me some good points I covered on those non-functional requirements.
Sure, here's a summary of what you covered today. Requirements. Confirmed. Create a URL shortening service that can handle 100 million URL shortenings per month and support 10,000 requests per second for redirections. Provide different tiers for free and paid users with appropriate rate limiting. Ensure low latency and high availability globally. Input original long URL. Process. Client submits URL through a RESTful API. API gateway routes the request to a load balancer. ECS services or AWS Lambda functions process the request. Shortening component generates a unique hash for the URL. Mapping between the original URL and the shortened URL is stored in DynamoDB. Output, shortened URL returned to the client. Consumer path input, shortened URL, process. User clicks on the shortened URL, hitting the redirect endpoint. Redirect service, AWS Lambda, looks up the original URL from DynamoDB. Response to the client with an HTTP 302 redirect to the original URL. Output, redirection to the original URL. Design considerations. Use CDN, e.g. CloudFront, to cache and distribute shortened URLs globally, reducing latency. Implement a cache layer, Redis, to handle frequent read requests and offload DynamoDB. Use DynamoDB TTL for automatic expiration of shortened URLs. Handle hash collisions by incorporating additional inputs to the hash function and using multiple hashing layers. Implement a write-through or write-behind strategy to keep the cache synchronized with DynamoDB. Provision DynamoDB read capacity to handle peak loads, and implement cache warmup using popular URL storage. Implement circuit breakers to manage back pressure during high load situations. Good points covered. Thoughtful approach to handling large-scale traffic and ensuring low latency through CDN and caching strategies. Consideration of hash collisions and strategies to mitigate them. Effective use of DynamoDB TTL for managing URL expiration, ensuring fault tolerance and high availability by leveraging AWS services like Lambda, DynamoDB, and CloudFront. Detailed consideration of cache warm-up and back pressure management to maintain system performance during high traffic. You've clearly demonstrated a comprehensive understanding of the requirements and provided a robust design to meet them. Well done.
Oh, thank you. Yeah, that's for the mock interview today. And thanks for your help.
You're welcome. It was a pleasure to assist you with your mock interview. Best of luck with your preparation, and feel free to reach out anytime you need further help. Have a great day.